Moving on with the convolution topic, let's keep working with this convolution example. If you remember in the last lecture, we had this guy over here, which is the x. Let me rewrite here the x of tau, which originally was x of t. So this tau is a kind of a dummy variable. Why the tau uh, is necessary here is because if we want to shift this h of minus tau from, or we need to translate this or displace this to the left or to the right, we cannot do that using only the values of t. So we need to create a dummy variable like the tau variable, so we can have this tau and the parameter, in this case t, as a reference, so we can shift this h of minus tau either to the left or to the right to get our results. Okay, so this is the h of tau, and this is the x of tau, and this is the h of minus tau, and this is both functions the same as we represented in our last lecture. Um, Now, this is the general form of the h of t minus tau. We are expressing here in this general form, a is equals to minus 3 plus t and 1 plus t, because this is the values of tau, and this will be the values of t. So this h of t minus tau will become this general expression. That's the reason why we don't have any reference line here indicating the zero, because there is no zero here. We are moving this h of t minus tau to the left or to the right, just as indicated by this tau value in this graph. So if we have here this first example, let's suppose that we have the 1 plus t. The 1 plus t is the edge in the front, this one. This is the edge of the front. And this edge of the front is 1 plus t. So let's suppose that this 1 plus t is less than minus 1. What does that mean? Well, this is the minus 1, which is the lower boundary of this x of tau function. And the h of t minus tau equals this function here. So we are going to keep this edge front in the front. This is 1 plus t at any value of t less than minus 1. So in this case, we can conclude, or we can say, that there is no overlap. And when we have overlap, the overlap is when we have this overlap area. So this is the overlap from A and B. And when there is no overlap, we have something like this. So there is no overposition of these first and second functions, one on the top of the other. So here is no overlap, and here we have yes overlap. Okay, so that's the meaning of overlap. And in this case, if we integrate the product of x of tau, which is this one, and h of t minus tau, if we integrate the product of both, we can come up with a zero value, because there is no area between in overlapping from one h or x of tau on the top of the other. So this is in this case, the result will be zero for this integral. Let's work another case. Let's say that this 1 plus t, which is this h over here, is equal or greater than minus 1. So in this case, this is the h of 1 plus t, and this is equal or greater than minus 1, but is less than 1. So this edge cannot be uh, to the right on this far, or it cannot be far away from to the left from this -1 value. So this is a representation of what this value will look like. And if we integrate this, we can now use this region of integration that goes from -1 to 1 plus t, which is the area that I am highlighting here in the shadow. This is little diagonal lines representing this region of integration. And now because we have some overlap between the h of t minus tau and the x of tau, then we can end up with this integral, which is the area, because the height of this function is equal to 1. So this is 1 and this is 1. And if we integrate this from -1 to 1 plus t, we will end up with this the integral for d of d tau. And this is an easy one. So we substitute the functions and the values of this from 1 plus t minus -1. We will end up with this integral equals 2 plus t. Okay, so that's the expression that we resume this integral, and it is the convolution integral for this overlapping area between x of tau and h of t minus tau. So if we simplify this boundaries here of these bounds, we simplify them, then this is the first one, 1 plus t equal of or greater than -1. If we solve this inequality, we can move this one to the right. So we will end up with this t um, equal or greater than -2. And in this case, 1 plus t is less than +1. If we move the 1 to the right, then we will cancel and we will have t is less than 0. So the domain region for this t value to get an integral of this is that t is going from -2 and up to less than 0. Okay, and this is one example of what the convolution is and how can we calculate the convolution of two functions.